Images of the universe that have never before been seen are only now beginning to emerge from the James Webb Space Telescope, better known as the JWST. This new telescope has undoubting clarity that will enable researchers to gain deeper understanding of how the cosmos evolved from the Big Bang to the present. However, one session based on some of the early photographs caused a bayonsy and received a lot of media attention. In particular, scientists and science author Eric Lerner suggested that the JWST disproves the theory of the Big Bang. Let's examine that hesitation to determine how to answer it. There was an article that claimed the JWST observations and far-off galaxies refuted the Big Bang, which is untrue. The article was originally published by a group called the Institute of Art and Ideas and is now being republished on mainstream news websites. The article's author, independent researcher Eric Lerner, has consistently rejected the Big Bang theory since the late 1980s in favor of his own pseudo-scientific alternative. The assertion of Eric Lerner is not new. He really made this assertion in his book, The Big Bang Never Happened. A startling refutation of the dominant theory of the origin of the universe, which was published 30 years ago in Lerner Plasma Cosmology, electromagnetic forces ruled the universe at large-scale dynamics rather than gravity. As in Big Bang cosmology, Lerner contends that the universe had no origin of plasma physics to control the creation of galaxies, stars, and all other aspects of the universe. Additionally, according to Lerner, his model does not require dark matter and dark energy extracts from the Big Bang. And as one might anticipate, both the data Lerner used to refute Big Bang cosmology and the data he used to support his model received recognition and discussion from the scientific community. Although Lerner's cosmology was last revisited in 2003, the objections are still relevant today. According to Lerner's most recent claims, the new JWST photographs support his plasma cosmology and disprove the theory of the Big Bang. But we must proceed with prudence. The observations of the cosmic microwave background, known as CMB radiation by Planck and others, and measurements of the distance or redshift relationships obtained from seeing galaxies throughout the universe provide the best evidence for the Big Bang cosmology. None of the JWST photographs affected this proof. First off, the JWST was not built to observe the CMB and cannot do so. Second, JWST was built to explore far-off galaxies and high redshift to learn more about the characteristics. No JWST data currently available refutes the overwhelming evidence that redshift systematically rises with distance. Some distant galaxies discovered by JWST are larger and more advanced than predicted by many Big Bang theories. These galaxy observations, according to Lerner, refute the Big Bang theory while correlating with the results of his plasma cosmology. The physics theory of the Big Bang event explains how the cosmos grew from a highly dense and hotter star to the present condition. The evolution of the observable universe from the earliest known times up to its later large-scale form is explained by several cosmological models from the Big Bang. A wide range of observable phenomena, such as the number of light elements of the cosmic microwave background or CMB radiation and large-scale structure, are all thoroughly explained by these models. Cosmic inflation, or the abrupt and extremely rapid expansion of space during the universe's early moments, provides an explanation for the uniformity of the universe as a whole, sometimes known as the flatness problem. But there isn't a whole widely recognized quantum gravity theory in physics that can accurately simulate the Big Bang's early conditions. Most importantly, these models agree with the Hubble and Metro law, which says that galaxies move away faster from a distance greater than 1. The models describe an increasingly concentrated cosmos preceded by singularity, where space and time lose meaning, extrapolating this cosmic expansion backward in time and using the known laws of physics. The CMB was discovered in 1964, which convinced many cosmologists that the competing steady-state model of cosmic evolution was falsified, since the Big Bang models predicted uniform background radiation caused by high-energy particles. The Big Bang event is well supported by a wide range of empirical evidence and is now largely recognized by everyone. Extensive observations of the universe's expansion rate put the Big Bang singularity to the estimated age of the cosmos 13.7 billion years ago. The Big Bang models are still unable to fully explain some elements of the known universe. Following its initial expansion, the universe cooled down to a point where subatomic particles ended later. The gravitational effects of an unidentified dark matter in cycling galaxies are observed by astronomers. The majority of the gravitational potential in the universe appears to be in this form, and according to numerous studies, the surplus gravitational potential is not produced by baryonic matter, such as regular patterns as suggested by Big Bang theories and other discoveries. Supernovae redshifts have been measured, and the results show that the universe's expansion is speeding up. This observation has been linked to the mysterious phenomenon known as dark energy. It's important to keep in mind that similar contradictions can be found in science quite regularly. In the case of professional development as a scientist, you may read papers with star ages that exceed the age of the universe, cosmic structures that are too large to have formed given the age of the universe, the measurements that demonstrate the CMB is too smooth to have produced stars and galaxies in clusters of galaxies. It's interesting to know that the evidence that led Lerner to agree with his alternative cosmology module included that last piece of information. But in each of the major cases, an additional study by the scientific community led to a clearer, more accurate comprehension of Big Bang cosmology. We now understand that they are required to report in the CMB that eventually gave rise to the structure we observe in the universe, created by quantum fluctuations in the very early moments of the universe. Additionally, researchers have examined the dimensions of those structures and the CMB waves to support the enigmatic dark energy, which accounts for around 70% of the universe's energy density. Sometimes more research gradually gets rid of the erroneous measurements. The same is true of differing star ages. The majority of older-than-the-universe stars are now younger than 14 billion years old. Analysis of a small number of stars, though, still yet ages that are slightly older than the universe, scientists anticipate a resolution as their inquiry continues. Sometimes resolving one contradiction leads to another one that was hidden before. For instance, we currently understand that the age of the universe is 13.8 billion years. The age is determined by calculations based on the redshift and distance equation. However, an investigation of the CMB waves yields data closer to 12.5 billion years. Scientists are happy about these differences because they offer helpful guidance for future researchers to better understand how Big Bang universe in light of the abundant evidence supporting Big Bang theories. Alternative models like Eric Lerner's are frequently created by scientists, even with general real activities and numerous experimental successes. Some researchers prefer a different strategy known as MOND, where they tweak Newtonian dynamics, MOND and GR, or general relativity. Simulations may frequently explain that agent arrived from cosmological observations. Many scientists are drawn to MOND because it eliminates the need for dark matter or dark energy, therefore solving the conundrum of the existence. This technique has the drawback that MOND does not offer a mechanism for describing how gravity operates. That mechanism was explained by general relativity as a result of the curvature of space-time. However, Lerner plasma cosmology merits a spot at the table of theories that attempt to explain how the universe came to be when theory and observation are in harmony, science develops, and astronomers are still discovering new things about the early cosmos because of the amazing data that JWST is providing. The irony is that Big Bang model is actually being supported by JWST data, which revealed that the initial galaxies were smaller but became bigger over time as predicted by Big Bang cosmology. Despite what Lerner and other science skeptics claim, science is never black and white, constantly learning and refining beliefs, and there is no covert blot silence dissent. Sciences are mostly founded on observation and evidence, which the bank offers in spades. That's not to suggest that people shouldn't be able to ask questions. Rather, the intelligent inquiry takes place inside an environment of open-mindedness, devoid of preconceived data, where views are formed by evidence rather than the other way around. Therefore, the next time you read someone denying the existence of the Big Bang, the Earth's flatness, or climate change, don't take what they're saying at face value. Question them about their proof and hold it to the greatest standard. Alright guys, this wraps up our video for today. Do well to give a thumbs up and don't forget to subscribe.